Good day, 5th grade mathematicians. Today's lesson in the entry task booklet is day 113. Let's read problem number 1. Which fraction model best represents the expression 4 times 3/8? So remember, when we have multiplications, one of the things that we can do is we can think of copies of. So which one of these has 4 of something? And we're looking for 4 copies of 3/8. So if I look at problem A, I see that I have a box that is broken into eighths, and 3 of them are shaded, and I have 4 identical copies. So there we go. And just to double check on the other ones, B is made up of eighths, but there are 3 copies of 4/8. And C is made up of tenths. So that's 3 copies of 4/10. And D is made up of 6, and we have 4 copies of 3/6. So A would best represent that expression. I'm going to move on to problems 4 and 5, and then I'm going to put my scratch pad up and do problems 2 and 3. So problem number 4, select all attributes, and notice that the word all is bolded. All the attributes that classify this polygon as a rectangle. What is a polygon? Yes, it is a many-sided object. So what makes a rectangle a rectangle? Are the opposite sides parallel? Are those sides parallel? Yes. How about these sides? Those are opposite. So are opposite sides parallel? Yes, they are. Are all sides the same length? Well, we can look at that. We don't need to get a ruler because that is just obvious that no, this one we're going to cross out. Does it have 4 sides and 4 angles? So we count the sides, there are 4 of them, and yes, it has 4 angles. That makes it a quadrilateral, and a rectangle is a quadrilateral. And then the last thing is a rectangle has to have all right angles. In other words, you could put a box in there and fit perfectly. So yes. So that has opposite sides being parallel, 4 sides, 4 angles, and all right angles. Okay, moving on to number 5. Patterns A and B are generated from using these rules. For pattern A, we're going to start with 10 and add 5. So 10, 15, 20, 25, 30. I'm just going to do 5. And pattern B, start with 2 and add 1. 2, 3, 4, 5, and 6. All right, so which statement best describes the relationship between the corresponding terms of pattern A and pattern B? Each term in pattern A is 1/5 of the value of the corresponding term in pattern B. So pattern A is the top pattern, and we see that that is not true because those are all bigger than pattern corresponding terms in pattern B. So it can't be a fraction of the size. So we're going to cross out A. Oops. That. Okay, and then for B, each term in pattern A is 4 times more than the value of the corresponding term in pattern B. Well, let's check it out. Is 10 4 times of 2? No, that's not true. And if one thing is not true, then the whole rule or statement is not true. C, each term in pattern A is 5 times the value of the corresponding term in pattern B. Well, yeah, is 10 5 times 2? Yep. Is 15 5 times 3? Yep. And we're just going to double check and make sure that all of those work, and we see that that does. So yes, C is the actual correct description. Okay, so right now I'm going to get my scratch pad here and bring that up there. And oh, we got to get rid of some previous work. And there we go. So problem number 2, you guys should be getting really good at these. Enter the number of pounds equal to 88 ounces. So we start with 88 ounces, and we want to know how many pounds that is. We're going to state what we know. We know that 16 ounces is 1 pound. And we know that we are going from ounces to pounds. So we're going from a smaller unit of measure to a larger unit of measure. So we are going to be dividing 88 divided by 16. Okay, so how many 16s go into 88? Well, let's count by 16s. 32, 48, 64, 80, and 96. That'd be too high. So how many 16s go into 88? Well, we see 5, right? 5 times 16 is 80. And we have 8 left over, so we're going to have 5 and 8/16, which is, if we simplify that, 8/16 is the same as 1/2. So we have 5 and 1/2 pounds. So 88 ounces is the same as 5 and 1/2 pounds. And the next problem, we are to enter the exact value of the product of 6 times 2/3 added to the sum of 2/8 and 3/8. So first thing I'm going to do is I'm going to figure out what is 6 times 2/3, because we do what's in parentheses first. And 6 times 2/3 is the same as 6 times 2 divided by 3. All right? Which we can do some cross canceling. 3 goes into 3 one time, 3 goes into 6 2 times. So 6 times 2/3 is equal to 4. And then 2/8 plus 3/8 is 5/8. We simply add the numerator. So now we're going to add 4, the product of our first term, our first expression, plus the sum of our second expression, and we end up with a grand total. The sum of those two expressions is 4 and 5/8. Whoops. So 4 and 5/8. There you